Okay, next we go for example number 3. Okay, if you can see here, example number 3 is all about a large tank open to atmospheric, filled is filled with water to a height of 50 mm. So the height is 50 mm. Then from the outlet tap, the tap near the bottom of the tank is now open and water flows out from the smooth and rounded the outlet. Determine the water velocity of the outlet. So the water is passing through the outlet of V2. So in this case, so the question asks for us to find the V2, okay, the velocity at 2. Okay, okay, so okay, so what should we do is, the first step is, okay, write the Bernoulli equation. So in equation, P1 divided by rho plus V1 squared divided by 2 plus GZ1 is equal to P2 divided by rho plus V2 squared divided by 2 plus GZ2. Okay, the second is information. Okay, in this case, okay, based on the previous, okay, we know that okay, at P1 is atmosphere, so automatically you know that P1 is equal to P ATM, so equal to 0 in terms of gauge. Then the second one, V1 is equal to 0 because of, so the flow is in initial is stagnant, okay, there is no movement, and Z1 is equal to 5 meter. Okay, for point number 2, our P1 is equal to P ATM also, and equal to 0 because of the valve is open, so the pressure here is similar to the pressure of atmospheric. And V2 that we need to find, okay, determine the water flow velocity, and Z2 is equal to 0 because of this is the datum of this tank. So come back to the step number 2. Okay, so we know that P1 is equal to 0, V1 is equal to 0, and Z1 there is a 5 meter. Okay, and P2 is equal to 0, V2 is equal to what we want to find, and Z2 is equal to 0. So step number 3, we need to finalize the equation. So back to the Bernoulli equation. So what you need to do is, P1 will be 0, automatically we cancel the P1. Okay, so 0 means there is no involved of so V2 is 0, and P2 0, and Z2 0. So here your final equation, Bernoulli equation, is GZ1 is equal to V2 square divided by 2. So Z1 is equal to V2 square divided by 2G. Okay, so step number 4, answer it off, complete the questions. Okay, so what you need to do is, we know that V2 is equal to square root of 2G Z1. So it's equal to 2G is 9.81 meter per second square times and Z1 is 5 meter. So your final answer is 9.9 meter per second. Okay, so V equal to square root of 2gz, also called as a Torricelli equation. Okay, next we go for example 4. Okay, in this example is about a piezometer which and a pitot tube are tapped into a horizontal water pipe to measure the static and stagnation dynamic pressure for indicated volume water column height. Determine the velocity of the center of pipe. So the question asks us to find the V1. Okay. Okay, in these questions, the same method. First is write down your Bernoulli equation. So P1 over rho plus V1 squared over 2 plus GZ1 is equal to P2 over rho plus V2 squared over 2 plus GZ2. Okay. Second step is information. Okay, here we know that what is the information is at point 1, okay, point 1, P1 there is a value. So for V1 also there is a value because of velocity flow in this area, and Z1 is equal to 0 because of the point is the same. Okay, so for P2 we have the value, okay, which is rho GH, and V2 is equal to 0 because of stagnation point. As I mentioned previously, the moment that flow move and meet the stagnation point, the V equal to 0, and Z2 is equal to 0 because of there are no elevated. So then step number 3 is finalize your equation. So your final Bernoulli equation will be P1 is, there is a P1, V2 also have, Z is 0, for point number 2, V2 0, Z2 0. So your final equation will be P1 divided by rho plus V1 squared divided by 2 is equal to P2 divided by rho divided by rho. So the question wants us to find V1. So we can take the V1, you will get V1 squared divided by 2 is P2 minus P1 divided by rho. Okay, so this is your equation. Then step number 4 is answer it or complete it. Okay, so here we know that in order to answer this one, we know that P1, okay, P1 is pressure at point 1 is from here to here, so it will relate with rho GH. Okay, so means it will be rho G and H. In this case, H is H1 plus H2. And P2 is point here, is from here to here, so it will the formula is rho G H1 plus H2 plus H3. Okay, so move it here, easy for us to explain. Okay, so in order to answer this, what you need to do is you need to put everything inside of your equation. So your V1 square divided by 2 is P2 minus P1. So which is your P2 is rho G H1 plus H2 plus H3 minus rho G H1 plus H2. Okay, divided by rho. So here we know that H1 will be cancelled, H2 also will be cancelled, rho and rho also can be cancelled. G, okay, you need, so it means that the final equation is V1 square divided by 2 is equal to G H3. Okay, G H3, or V1 is equal to square root of 2G H3. So we can answer it, V1 is equal to square root of 2, G is 9.81 meter per second square. Your H3 is, what is your H3 is? H3 is 0.12 meter. So at the end you will get the answer of 1.53 meter per second. Okay. So what you need to remember here, this is the step that you can use it. Okay, the step. First step is write the boundary equation. Second is put all the informations. In the informations there is several important thing is you need, it depends on the questions. For example, in terms of pressure, if the pressure is open to atmospherics, so we can take it as pressure is equal to 0 due to the gauge pressure. Okay, for example, velocity, if is a starting velocity is like a tank, so there is no movement, so V1 we can assume is as a 0, and Z is related with the distance. So if your Z1 is your datum, so should be Z equal to 0. If your Z1 and Z2 have the similar point of there is no elevated, so Z1 is equal 0, same as a P2. If your P2 is open to atmospheric, so equal to 0. If your V2 is related to the velocity of 0, stagnation point for example is 0, and Z2 if there is elevated, and also 0. So this is the main thing that you need to answer in order for you to cancel the Bernoulli equation, for you to get the final Bernoulli equation. So once you get the final Bernoulli equations, so you can start to answer it based on the information given. Okay, so then just answer it and you will get the answer. Okay, so the most critical thing for me is, first is Bernoulli equation, second is how to declare the informations. Okay, maybe we can put it some simple summary, where is in pressure normally it will relate with 1. Okay, in terms of pressure it will relate with PATM. If it opens only is equal to 0. Okay, or okay, in terms of V there is a 2 point, point number 1 is initial velocity. So initial velocity v equal to 0. Number 1 is stagnation point, so v equal to 0. So for Z, the requirement is 1, no elevation, and number 2 is sim level. Okay, pressure, okay, pressure, okay, thank you.